What I'm going to do is I'm going to give you the key for chapter 10 for this section, 10.1, 10.2. Problems 1 through 8, I went ahead and did that with you last period. So the instructions here are to graph the function on the same set as the parent function. And I do have the parent function on my Inspire. So make sure that you type the equation to the calculator and show your table. So when x is -2, y is -8. When x is -1, y is -1. When x is 0, y is 0. When x is 1, y is 1. When x is 2, 8. So this is just a portion of the table. It doesn't make sense to graph the other ordered pairs since I can't graph them. So we have -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. This is the parent function. Now I'm going to graph this function, which we have x minus 4. And remember, in our lesson for transformations, the -4 is going to shift to the right 4 units, and the +1 is going to shift it up. So go to tab. In this case, it's going to the table here. So let's go ahead and press menu, and we're going to go ahead and remove the table. We're going to press tab and type in the function, and this is related to the parent function. So we have x minus 4, and we have this raised to the 3rd power, plus 1. Press enter, and you notice that the graph will shift to the right. Now, when we go back to our table, it's going to have an option here to lower this to see the second table, and that's the one we want. You notice that we know that the x-intercept is 4, so we should be around 4. So yeah, I'm going in the wrong direction. So we should start with 2. So I'm going to use a different color. So I have x and y, and we're going to start with 2, -7, 3, 0, 4, 1, and then of course I'm going to scroll, 5, 2, 6, 9, and I think I'll stop there because I'm not able to graph those other points. So we're going to start at the origin, go over 2, then go down 7, start at the origin, go over 3, and there is our x-intercept. We'll go to 4, 1, 5, 2, 6, 9, and so I'm going to go ahead and graph it. And you notice our graph did shift to the right, but it also went. On this part of the assignment, we had to name the x-intercept. We're going to go ahead and do number 2. So I'm going to go to on, new, graph, and I'm going to go ahead and graph g of x, which is control, and then that symbol, and then we have x plus 3, press enter, and you notice that the x-intercept is where it crosses the x-axis. It's -1, -2, -3. So you write -3, comma 0. Also, you can look at your table, menu, table, split screen. So if I go to -3, and I'm going to go ahead and move up, there's your x-intercept. For number 4, it says name the wideness of each function. I went ahead and graphed the cube root of x plus 9. And you notice that it's going to be 0, 9. Now you can also see it in the equation. So I give you the answer for number 3. As you notice, the y-intercept is 3. So this one is 0, 3. And the answer for number 1, I did give it to you in the class, so that's going to be 5, 0. Okay, we're going to, for this part, for number 5 and number 6, we are going to find the local maximum and minimum point for the given interval. So if you look at, we have 0, -3, and then we have 7, -2. And you notice that -2 is closer to 0, so that's going to be your maximum point. So I'm going to write max point, which is 7, -2. And our minimum point, so that's our minimum point, 0, -3. So to find the inverse, we went ahead and switched the x and the y for the original function. So in this problem, we have to graph the cube root of x plus 6, and we also have to graph its inverse. So we have -1.44 and -9. Then we have -8, or -1.25 and -8. -1, -7. 0, -6. 1, -5. 1.25 and -1.44 and -3. And then we have 2, so that's something like this. So this is f. This is the inverse of f. And this is f of x. So we're going to go ahead and type in g of x equals the cube root of x minus 9. And we're going to graph its inverse. So we're going to go ahead and at this point I'm going to go ahead and do a new graph. So we're going to go control, and now we have the cube root of x minus 9 going to be over here. Go to menu, graph. So let me go ahead and graph the table. We have x and y. We have -1.25. Actually, it's 7 and -1.25. 7 and -1.25. 8, -1, 9, 0. 10, 1. We have 5 and -1.5. And we have 6 and -1.4. We have 7, -1.2, 8, -1, 9, 0, 10, 1. So it looks something like this. So now we're going to write the inverse. And the inverse, we're going to switch the x and the y. We have -1.25 and 7. We have -1 and 8. 0, 9. 10, 1. I'm sorry, 1, 10. 1, and there's our inverse on our graph. The graph of g of x can be obtained from the graph of the parent function using the given transformations, write an equation. So for number 10, translate the graph to units up, reflect over the y-axis. So we have g of x, equals graph to units up and reflect over the y-axis. So it's cube root of -x plus number 12. Vertically stretch a graph by a factor of 2. So it's going to be g of x equals 2 cube root of x, and then translate 6 units to the left, plus number 14, horizontally stretch the graph by a factor of 3. Horizontally stretch the graph by a factor of 3. So it's going to be g of x equals cube root. It says to reflect it across the y-axis, so it's -1/3. The negative will reflect it over the y-axis.